Learning to decompose numbers, pulling them apart and putting them together again, is not the sort of thing that we can feature in an occasional lesson and expect students to get it. In order for children to develop the kind of ease with decomposing number that they really need to have, we're going to have to make it a regular staple of their mathematical diet. However, this does not mean that we need to sacrifice our math curriculum to this topic. It turns out that learning to decompose numbers lends itself to short but meaningful experiences that happen frequently. Researchers call this distributed practice. With intentionality, we can also use these short experiences to foster children's experience with different kinds of representations and to provide opportunities for them to seek patterns for the way numbers behave, and also to model more abstract representations that we want students to have experience with before trying on their own. So we're going to take a look at number talks as an ideal classroom routine for learning to decompose number. I mentioned in the previous lesson that the idea of decomposing number was foundational to the operations and algebraic thinking domain. It is also evident in standards in the counting and cardinality domain and the number and base 10 domain as seen here. We can even see part-whole relations cropping up in the kindergarten geometry domain where shapes are involved rather than numbers. Clearly, learning how to think in terms of parts and a whole or a total is a foundational aspect to mathematics. So let's take a look at how number talks can be used to develop this kind of capacity in our learners. And so first we'll need to know what a number talk is. Number talks are very different from a typical math lesson. In fact, they frequently do not even happen at the same time of day. Oftentimes, number talks are part of a morning meeting, for example. The number talks are much shorter than lessons, for one thing, and the primary focus is definitely not on what you can cover or what you can present or what you can accomplish. In fact, the focus isn't on anything that you as a teacher do at all. The entire focus is on what will students do when they're presented with tasks that require them to think about numbers. How will they see the numbers? Are there other ways to see the numbers? Can you make sense of those as well? What relationships or patterns can be detected by the students? How can we model what you just told me using number bonds or an equation? A number talk is a breeding ground for student thinking, so the teacher's ideas are really out of the picture completely. The role of the teacher is to pose tasks that will elicit student thinking and or to pose sequenced tasks that have an inbuilt suggestion or concept embedded in it. The teacher serves two primary purposes during the actual number talk. He or she models the student's thinking, often with number bonds and equations, sometimes with some of the visual images. Maybe a dry erase marker is used to illustrate to the whole class how that child thought about the number. And also, the teacher's role involves fostering dialogue on the part of the students about perceived mathematical relationships. Some students, for example, might notice essentially an idea where they're getting at the commutative property, and you want to pull that out and find out what other people think about that and really build that mathematical dialogue. So for a number talk, it's not a teacher tell time. That isn't to say that during the regular lesson that might not be appropriate at times, but it isn't part of a number talk. In order for number talks to achieve their potential in your curriculum, there's some criteria that need to be in place. A key aspect of number talks is that they need to be a low-risk environment for the learner. In other words, the learner must feel free to take risks, try out their ideas, and not fear being wrong. If there's a stigma to being wrong, they'll play it safe and they won't try. They won't give their ideas out, they won't share their thinking, they won't try something new, they'll always want to play it safe. It'll be very hard to get new ideas out on the table and people willing to share their thinking for it to be part of a dialogue. So a number talk needs to have some classroom norms that communicate to all involved that this is an open and accepting community. Other features of a number talk include a focus on student dialogue and the non-judgmental reaction of the teacher. The teacher's role is not to say what's right and what's wrong. Even when someone is incorrect, we elicit their thinking, we elicit their reasoning, we get other students' input and what do they think about it. Oftentimes the students will refute one another. We don't need to. And We just have to make sure that that's done in the spirit of mathematical dialogue and not in the spirit of attacking people individually. Why do we have that idea where the teacher isn't the judgment role? Because we want children to develop their reasoning and their capacity to critique peers' reasoning. So it's not the teacher who's always in that role, but the peers can do it too. And we want them to have the capacity to evaluate their own thinking. The number talks can vary considerably in their appearance. Some use 10 frames, some use dot cards or dice images, some use math racks. Generally, though, the first task is fairly easy for the students, and often as you progress through the sequence, they get more complex as you proceed through your sequenced tasks. The relationships that you worked with in the first tasks often support you in figuring out how to do a later task. You can use the sequence to shift students from their current representations and their current thinking, things that seem easy to them, into more abstract or more difficult ways of thinking by setting up your sequence intentionally. Also, for kindergarten, it's very appropriate for your sequence to be largely in the format of visual types of representations. For later first grade and on into upper grades, a lot of times the number talks use symbolic formats like equations, but for kindergarten, the ones I will illustrate for you are all image-based because children can be strategic first with images. They do need to see multiple representations. It does need to be followed by dialogue, and then following that you can model how to write number bonds and equations that match the thinking that they have already done. The multiple representations in the dialogue get students to see how the representations are connected, and we've already talked about the importance of making connections between multiple representations. And although we've said it before, it bears repeating that the focus is on the student thinking. They may not notice something that you'd like them to notice, but maybe today's not the day that that discovery will come out in the open, maybe later. It isn't the time for you to actually tell. So if they don't notice something, maybe they're not ready to notice that thing, we just chalk that up and move forward. Maybe if we really think they should notice it, we can find a way to make it more evident in a future number talk. When you sit down to plan a number talk, here are some good questions to guide you. Initially, this is going to take a while, but as you get a mindset for how number talks work and how they're structured, it will come together much more quickly and naturally. Basically, you need to choose representations that will connect with your learners right where they are in their thinking, keeping in mind that they need to become accustomed to using more than one kind of tool so that they can see transference of mathematical ideas across tools. So sometimes you have a number talk that has more than one tool within the same number talk. Sometimes you stick with the same tool per number talk, but across many number talks you've used a whole variety of tools. Sequencing of the tasks is especially important when you want to get some new strategies in the repertoire of your students. You need to consider what important ideas you hope the dialogue will uncover so that you can be looking for every little opportunity in things that students say and the kinds of thinking that they are discussing to get at those foundational mathematical ideas. Also consider what you might want to intentionally model. Math is often difficult for children because of its abstract symbolic language, and children need extensive opportunities to see that language of math being modeled in ways that connect to their thinking. Number talks are a great way to build in that long-term modeling. Also, vocabulary can be introduced and modeled for quite a while before children need to internalize it and use it on their own as part of their regular everyday math language. Especially when the number talk brings out some new ideas that are not yet solidified, you may want to plan a reinforcement task that could be used as a follow-up lesson or in a math center or as math homework. We'll talk more about reinforcement tasks in the next lesson. Student thinking, particularly student thinking about mathematical relationships and properties and how to use them strategically, is really the linchpin of the number talk. So give some thought about what kind of student dialogue you hope will occur as a result of your chosen tasks. Here you see several ideas for focusing the dialogue at kindergarten, although to be honest, in this particular lesson, we're focused almost entirely on that first bullet point. But some of those other ideas are also very appropriate for kindergarten. If students are going to get the most out of a number talk, there needs to be widespread student engagement. There can't be a situation where students think they're mentally off duty when another student is sharing their thinking. If that were the case, then a lot of children would not get any benefit by hearing other children and their ideas. And of course, we really want it to be kind of a crock pot or a breeding grounds of new thinking, which means you have to hear what other peers are saying, decide whether you agree or disagree, how was that similar or different to your own thinking. One of the ways that I incorporate explicit guidelines that clarify the student's role during think time and share time is through a looks like, sounds like T-chart, which we can review as often as necessary at the beginning of our experiences with number talks. I also really like the use of dipsticking signals. These signals give the child a way of communicating to me without interrupting the class or anyone else's thinking, and they also give me some formative feedback about how each of the children are responding to the problem. So I have signals that they can give me for I'm thinking right now. There are signals for I have a strategy, even though they're not sharing it. There are signals for if I have more than one strategy. There are signals for I agree, there are signals for I disagree, and there are signals for I've thought of it the same way, so same. And these signals that they have allows everybody in the classroom to actively contribute without all talking over one another. And yet I can look and quickly use those signals to get a feel for how the class is responding. You normally expect that a certain portion of your class will pick up on a new target concept immediately, and that others are listening and you can tell they're processing, but maybe they need a little more time to fully internalize the idea. The idea could be something like the commutative property. As that same target concept comes up in future number talks, however, you can monitor how more and more of your students are responding to it, and you should expect to see that more students catch on to that target concept as it comes back periodically. This is actually one of the beautiful things about a number talk, and that is that children are allowed to naturally develop an understanding of difficult concepts in a low-risk environment over time where they don't feel like they're obliged to do something immediately that doesn't make sense because of a fear of being judged. Number talks often have one of these structures. Often they're a sequence of quick images using visual representation such as 10 frames, dot arrangements, or math rack arrangements. This is actually most typical for kindergarten. They may begin with familiar images and then gradually change so that the child begins to see how they can mentally transform an arrangement, a visual arrangement, to make it easier to figure out a total quantity. Okay, we'll look at an example of that in just a minute. Sometimes a number talk is actually wrapped around a read aloud literature book with math connections, and I have an example of that type of number talk in the teaching resources section in a document called Sample Number Talks for Kindergarten. Number talks are ideally suited to address several of the mathematical practice standards. Okay, the focus in a number talk is on children's thinking and reasoning, which they're articulating. They respond to peers' thinking, deciding if they agree or not, and justify why. So there we're getting at mathematical standards of practice 2 and 3. The teacher is modeling the mathematics using visual tools and equations, and this is supporting children's development towards mathematical standard of practice 4. Many of the representations that the teacher uses will involve strategic use of tools, so appropriate tool use is also being facilitated for the learners towards mathematical standard of practice 5. The teacher can also model, facilitate, and evaluate how children, first of all, the teacher is using the vocabulary, and then how do children pick up on mathematical vocabulary and precision in calculation. So that can get at standard of practice 6. Strategies are typically based on number relationships and whether they're taking advantage of particular structures in the representations and especially with reference to unique things about our number system, like the number 10, for example. And when they do that, they're getting a mathematical standard of practice 7. So if you use a tens frame and somebody uses an idea that I knew it was 9 because there was 1 missing and 9 is 1 less than 10, that's using the structure of mathematics, mathematical standard practice 7. So number talks are a wonderful way to daily experience and develop children's mathematical habits of mind. Now I should point out that a particular number talk on a given day is just not going to accomplish all of these standards of practice. If it attempted to do so, it would do a pretty bad job. In indicating the potential of number talks to address mathematical standards of practice, it would be better if you focused first on the concept and then thought which of these kinds of ideas can be really fostered through this number talk, which of these standards of practice are likely to develop. Sometimes the students themselves will contribute something that fits well, and then if you are a prepared mind, you can pick up on that and help more students to access that kind of thinking. Now, our primary focus in the number talks we're discussing has to do with decomposing. So we're really looking at decomposing, but learning how to decompose and compose numbers is going to get at reasoning abstractly and quantitatively. That's how you learn to reason quantitatively, is by developing these number relationships of how you can pull numbers apart and put them back together again. But you also work with tens frames. You might be able to get at that look for and make use of structure. So as you think about a given number talk, plan in advance whether you might be able to really feature an opportunity for students to develop a particular mathematical standard of practice. If you develop a consistent commitment to number talks in the classroom several times a week, for example, week after week, and if you choose very specific representations that can draw learners' attention towards mathematical relationships, which they can ponder and make sense of and use to decompose and recompose number, and if you're able to use this to support children's capacity to dialogue, mathematical dialogue with their peers, then number talks will be not only yours, but one of your students' favorite ways to ensure that these mathematical standards of practice are characterizing the instruction in your classroom. The authors of Common Core have been very clear that these are not just for gifted students, and they aren't the sort of thing that we'll do on Friday afternoon or the day before a holiday. They should be the characteristic way that math instruction looks in your classroom on a daily basis. Okay, we're going to look at a couple of examples now. This is an example of a quick image sequence. Only one of these cards would be shown at a time, and the ABCD shows you the order in which they are sequenced. So you show the first image. It's a quick image, so you do not hold it up long enough for them to count by ones, just to get the image fixed in their mind, and then it goes down. So maybe about 3 seconds. This is followed by a short amount of think time as they process what they saw, and that allows the children to sort of mentally think through what chunks they perceived in the image. Now this process where they think about those chunks and put it together into a total is called conceptual subitizing. We discussed that in the Part A module, and it is discussed in the Common Core progressions document as something that has to happen at kindergarten. The reason it has to happen at kindergarten is because it's actually the foundation of many arithmetic strategies, and children are expected to develop those strategies in first grade. So in kindergarten, we prepare them for that. You can then call on the children to share how they saw the dots. Classmates can give signs of whether they agree or disagree, or whether they had the exact same way that they saw it. In this sequence, some children may see the first image as a column of 3 and a column of 2, but others may actually see it as a dice image of 4 with 1 dot on top. Some may even see it as a 2 and a 2 and a 1. So all of these different ways of seeing it can be documented. And early in the school year, you might just write it 2 and 1. Or a 2 in a circle, a 2 in a circle, and a 1 in a circle, something like that. But later you can actually model expressions, 2 plus 2 plus 1, and even later you can do it as an equation. Number bonds are also useful. The next image is a familiar dice pattern for 5, so I would expect it to be fairly quick with the students, but I'm really curious about whether anybody will think to connect it to the previous image. 5, is that just like last time? Does this look like last time? No? How is it different? Oh, well, the 1 dot that was on top is now in the middle. Somebody might say that. And so you can actually begin to see how this particular image here, B, can be decomposed as the 4 outside dots and the 1 internal dot, for example. Okay, and this goes on and so forth. But by the time you finish this sequence, the children themselves should have generated a whole variety of ways of decomposing the number 5 into 2 and 3, 3 and 2, 4 and 1. They might even with B go into 5 and 0, although that's actually the hardest of the combinations of 5 for the children to mentally grasp. Okay, now I'm going to give you an example of a number talk with the math rack as a different tool, and this involves the quantity of 8. Now when I do this with children, I actually have a physical math rack with beads on it that we can move. I really like the idea of them physically moving beads. However, there are almost certainly smartboard variations of this type of thing. I haven't played around with that a whole lot because I mostly like to use the real deal. You can also make homemade versions of these quite easily, and I'll try to put one of those in the teaching resources section. All right, this particular number talk is focused on the quantity of 8, and it begins with 3 plus 3, which really isn't 8, but it's a very familiar double for the students. At this point in time, it may be unclear why we're starting with that, but let's take a look at where we go next. The next image, oh, by the way, you see the equation there. That means that I've modeled after the students told me what it was, I modeled it as an equation. I might have modeled it as a number bond first and then as an equation. Depends where the students are in terms of their development with representations. So this image shows 3 on top and 5 on the bottom, but this is also the same as the previous representation, except there's 2 more on the bottom. So some of the students may have noticed, oh, you just put 2 more on the bottom. Oh, so it's like 3 plus 3 plus 2 more, and that's also 8. I don't know how many students will do this, but sometimes students amaze you. They might actually notice that 3 plus 3 is 6, 2 more takes you to 8. They might relate that to counting on by 2. And if you had a really advanced person in there, they might notice that that is a skip count or an even number. Even numbers are technically don't have to be solidified yet, but nevertheless, that may be something that pops up. Your goal as the teacher is to ask the students, how did you see the number? And then, based on the kinds of things they say, help the rest of the class to see how they saw it, and then extend their representations, but also pull out any interesting dialogue or relationships that the students discover and make sure that they have a chance to talk about that. We next shift to a familiar arrangement of 8 as a 4 and a 4, but it will be interesting to see if students can explain how that is the same as the previous quantity. What happened? Some students may be able to say, oh, well, one of the beads from the bottom went to the top. So that is actually a decomposition and a recomposing. Essentially, it's saying I took 1 away from the 5, which means I partitioned the 5 into a 4 and a 1. See, they just don't have that vocabulary, but they have that idea now. And I gave that one, recombined it with the 3. So now I have 4 and 4. This is a mathematical idea called compensation, actually. It's going to be an extremely important concept as one of the arithmetic strategies they're expected to use in kindergarten. I'm sorry, in first grade. Did I panic you there for a minute? Okay, after the student dialogue for each arrangement, you can say, okay, I'm going to model how mathematicians write what you just did. And when I get finished writing it down, I'm going to want to point to different parts of the way mathematicians write it, the number sentence. And I'm going to have you tell me, where do you see this on the math rack? So this is really important. I'm not just going to do this one way. I'm not just going to say, oh, first you saw 4, then you saw 4, then 4 plus 4 equals 8. Now I want to go back and say, where did this 4 come from? Oh, that's the number of beads in the top row. See, putting it into words as being one of the important representations that we're working with, where each part has meaning. As students look at the number sentences you created at the very end of the number talk, you can have them look at all of them together and say, just take a look at all of the number sentences that we wrote and see if you see anything that you notice that you would like to share with the class. Now they might notice that 3 plus 5 and 5 plus 3 are both up there. And you can say, oh, that's an interesting thing to notice. I'm going to read what this means in words, and I'm going to want to know if you agree or disagree. So listen carefully. Then you can point to the 3 plus 5 and go, a group of 3 and a group of 5 is the same as 8 altogether. And the last one means a group of 5 and a group of 3 is the same as 8 altogether. Ask them if they agree that that's true, and if so, how do they know that? How could they explain that to someone? Remember that your goal in a number talk is to see how far their own thinking can take them, rather than in teacher telling. So they're exploring some interesting aspects of the commutative property, but it needs to be their own thinking that's being pushed, but not teacher implanted at this point. Okay, if a student doesn't get it today, that's okay, because that concept is going to come back and come back and come back. Maybe today's not their day. Maybe soon there will be another day where it's their day to make sense. Unless you've had some experience already with number talks, you may be feeling a little overwhelmed at designing your own. Here I have a list of some of my favorite resources for number talks. The bottom reference is actually an article that gives more background on number talks. The second and third references here essentially are resources that are filled with lots of examples that you can immediately employ in your classroom. Once you get the idea of how a number talk works, you'll be able to design your own.